So here's our warm-up today. Which of the following is not supported by the diagram? So a lot of times our tests have questions that use the word not. So we need to be practicing with questions that have the word not and make sure that it doesn't trick us. Like, we knew the answer, but we accidentally chose the one that was true because we didn't see the word not. So we do need to be careful with those and make sure we read it really carefully. So go ahead and choose your answer, but please. All right, so point C is the intersection of line A, C, and line B, D. So this line intersects this line at point C. What I like to do on these is I like to put true by it. Because if I put true and false by each one, then they're all going to be true except for one, and that'll be the one I choose. So that's just kind of a test-taking tip. Points B, C, and E lie in plane F. So you're allowed to name a plane with one letter as long as it's a capitalized, kind of italicized, leaning over letter. So are all those points in the plane? B, check. C, check. E, check. So that is a true statement. C. Point E lines in plane FBC. There's only one thing wrong with selection C. What is wrong? You cannot name a plane with an italicized letter and then two of the points in the plane. Good. This is not the name of this plane. That is bad. Because they used the italicized F, which is not a point, and then they used 2 points. If you're going to name a plane, you have to name it using 3 points or 1 italicized letter. So this one is false, this one's bad, and then we know any 2 points are collinear, so of course part D is true. So the only one that was false was C, and the reason it was false was because they named the plane incorrectly. All right, here are your homework answers. Take some time to check those answers. Now, are you ever going to be graded on drawing, let's say, this and this perfectly on a quiz or a test? No. I'm not going to grade you on if you can draw those diagrams perfectly. But do you need to know what the diagrams look like based off of a description? Yes. So you need to kind of know what that would look like and be able to envision it, but I'm not going to grade your drawing skills with 2 planes intersecting because that's kind of hard to draw. Okay? So, will you need to draw C and D on a test? No. Do you need to be able to visualize what that looks like? Yes. All right, going over the homework. Postulates practice. 1B. 1B. So, 1A says 2 intersecting lines are always coplanar. Because if I have 2 intersecting lines, I can put a flat plane and contain both of these lines. I can make these flat, 2D. Okay? Now, part B says 3 intersecting lines. So what if I took these 2 and then I did this? Whoa, coming at ya. Now I'm 3D. I'm not 2D anymore. See how this is 3D instead? But I also could have put it like this, couldn't I? And now they're flat again. These are flat again. So I could make them coplanar, or I could make them non-coplanar. And that's why it's sometimes. Okay? 1E. A plane containing 2 points of a line always contains the entire line. We have 4 postulates. One of those postulates says 2 points determine a unique line. So if I have 2 points of this line, I have the whole line. Because through 2 points, there's a unique line. There's not 50 lines, there's 1 line. And you get all the points of that line. You get all infinite points. All right? 1H. 2 skew lines are never coplanar, because if you look at your definition of skew lines, which hopefully you studied definitions last night, skew lines by definition are non-coplanar lines that do not intersect. They're non-coplanar by definition. Therefore, they can't ever be coplanar. Okay, last one, 2C. Give an example of 3 coplanar points. I want to remind you of something very important. 3 points are always coplanar. I can connect any 3 points in the universe with a flat surface. Any 3 points in the universe are coplanar. So name 3 coplanar points. You could have picked any 3 points from the picture. Any 3 points. Now, is B a point? No. Is J a point? No. M is not a point and L is not a point. So any 3 of those, there's only 4 points on there. Any 3 of those 4. Okay, that's all we're going over for right now. Next, we're doing a super speedy lesson on constructions. What is a construction? Well, construction started over 2,000 years ago when the Greeks, actually I should show you this side, when the Greeks were coming up with geometric relationships and postulates. The way the Greeks came up with them was by using what we call a compass and a straight edge. So Euclid, the guy who founded geometry, or he gets credit for it, he used these only. That's all he used, a straight edge and a compass. And he came up with a lot of the things that we study today. Also, by using these 2 instruments that were used so long ago, it really gives us insight as to how geometric concepts work and when direct measurement is not appropriate, like using the ruler side of the ruler when we don't need to use that. Okay? So that's what constructions are. Like I said, in constructions, we use something called a straight edge. I'm going to call this a straight edge and not a ruler because you are not allowed to use the markings on the straight edge to do constructions. And then this is called a compass, of course. A compass will have a point and it'll have something to write with, something to mark with, like a pencil on one side. Okay? What shapes can we draw with a compass? So if we had a lot of time, I would tell you to just get an empty sheet of paper and just play with your compass. Just use your compass and move it around. We don't have a whole lot of time. But as you can imagine, a compass draws things like circles, or if you don't go all the way around, it draws things like an arc. How could we use just this guy to construct congruent segments? So that's what we're going to figure out through our practice worksheet today. So on your practice, it looks like this, segment constructions. I want you to complete part 1. Let me show you what it looks like. Part 1 says to construct a circle with center P. Alright, so if we wanted to construct a circle with center P, what would we need to put on point P? The needle part, right? We would need to put the needle part on point P. And I did not tell you how large to make the circle, so we all might have made different circles, but you would just move your compass around. And I know it's so much easier to do on the computer, right? So you put pressure on the needle and you twist it with your finger. Okay? So you twist it and your pencil should be touching the paper as it goes all the way around. Alright, so we might all have constructed different circles, but for what we're trying to observe here, it doesn't matter what size our circle was. The next thing says pick a point on the circle, name it R. Be careful. To pick a point on the circle is the collection of points that you just drew. So to pick a point on the circle, make sure you are actually, this is the circle. It has to be on the circle. It can't be inside the circle. It can't be outside the circle. It needs to be on the circle. Pick another point. Name it Q. Construct segment PR and PQ. So to construct a segment, it pretty much means to connect the dots. I guess I'll use a ruler. You have to use a ruler. You're supposed to use a straight edge. Let's see if my smartboard will. Nope, it did not like me using a ruler. So I'm just going to eyeball it, but you are using a straight edge. Before we move on from that, I want you to think about what is true about PR and what is true about PQ. Hopefully you're saying something like, well, the length of PR is the same as the length of PQ, right? Because these are the same distance away from the center because they're both radii of a circle. I'm kind of answering some of the questions that come below, so sorry about that. I'm getting ahead. Now it says to use the same compass setting. That means you don't open or close your compass. You keep it right where it was. And you come over to point T, and you construct another circle. You pick a point on it, and you call it U, and you construct TU. Oh, there's where it said patty paper. You were asking about patty paper. Patty paper is just paper that is transparent. You can see through it. So it's like tracing paper. So if you had the tracing paper, you would trace TU, and you would compare it to RP and PQ, and you would compare their lengths and see what's true about their lengths. Okay. What are segments PR, PQ, and TU called? They're called radii, or if you just put radius, that's fine. How does the length of PQ compare to the length of PR? They are you can put same or equal. What about the lengths of PR and TU? Also same or equal. What do you know about circle P and circle T? We know that they are congruent circles because their radii are the same length. When two circles have the same length radii, then those are congruent circles. Okay, so that was kind of showing you, giving you some insight as to how we're going to duplicate a segment using circles. That's how we're going to duplicate a segment using circles. So let's see what that looks like down here. Construct a copy of a segment. This is today's entire goal. Right here is to construct a copy of a segment. So if you leave with nothing else today, I just want you to know how to copy a segment, and you're going to be like, whoa, that was the easiest thing ever. So this is how you copy a segment. You take your compass. Where'd my compass go? There's one. You put the needle on one end point. You put the pencil on the other end point, and that's your compass setting. Keep it set there. So needle on one end point, pencil on the other end point. Then you go to, I already drew ray for you, but if a ray wasn't already there, you would need to draw your own ray. So then you go to your ray, you put your needle on the end point of the ray. Don't just put your needle anywhere on the ray. Put it on the end point of the ray and make an arc. Make a nice, pretty arc. Now, where that arc intersects the ray, that's your other end point. And you just copied a segment without using a ruler. You copied a segment using this guy right here. And that's all you used. Pretty cool. That's called a construction. Okay? Let's try another one. Yeah, okay. Construct a copy of line segment AB from the triangle onto the ray. Name the copy PQ. So this time, I'm going to come over here. I'm going to put my needle on A. I'm not sure if I'll be able to do this on the smartboard. because I need to put my pencil on B. I'm going to go the other way. But you get the idea. Needle on one end point, pencil on the other end point. And this is where it's probably easier for you than me. There we go. I'm going to call that close enough for me. That's your compass setting. You opened it up to AB and you're set. Now you come over here and you need to put the needle on point P and then you make your arc. Where the arc intersects your ray, what do you call it? It said to call the new copy PQ. So where the arc intersects the ray, you call it Q. And now I've constructed a copy of segment AB onto that ray named PQ. PQ is the same length as AB. Here's the last one I'm going to do in this lesson, and the rest you get to practice on your own. Given segment AB, construct segment MN such that MN equals 2AB. Whoa, what does that mean? So, 2 times something means we're going to double it. MN is going to be double the size, the length, of AB. Now, all of our other ones had a ray already drawn. This one doesn't have a ray already drawn. So we're going to need to draw our own ray. Let's see if I have that tool. Cool. I get to cheat. Okay, so you're going to use your straight edge, and you're going to draw your own ray on there using your, I'm not calling it a ruler, I'm calling it a straight edge. Make sure it has an end point because you have to know where to start. Okay. Okay, so in order to copy segment AB twice, let's see if it's going to let me do this. We're obviously going to copy it once, which you've already done. You're going to pull it right down here, put your needle on the end point and make an arc. And then we're not going to change our compass setting. We're going to take the needle and we're going to put it where the arc intersected this ray. You can put a dot there if you want. So we're going to start where we left off. We're going to start where we left off. We're going to make another mark. And that is our end point. So we're going to call it M, N, and that is our new segment, and it is twice the length of AB. What would this point right here be called? What would that point be called? Hopefully you're saying a midpoint. That would be a midpoint, and this would be congruent to this, but we're going to learn more about that in our next unit. All right, so the 2 problems that are left, you should practice on your own with your compass, and we can go over questions if you have them tomorrow. Your homework tonight is called Lines, Planes, and Their Relationships.